Okay, let's start. Some people said they couldn't be here, and then they want to meet with me, and then I have to do it 2 or 3 times in a row. So I'm videotaping it, so I can put it online and they can watch it. So I'm just going to give kind of an overview of the qualifying exam. It's essentially identical for development and genetics, so I do it together. So it is an exam. You will be evaluated and judged, not surprisingly. But from my perspective and your perspective, I think it's good to just kind of focus on what we look at as kind of the 3 important goals of the qualifying exam. One is really to catalyze students to gain both a broad and a deep understanding of their field, more or less as soon as they set foot in their thesis lab, so that's one. 2, it's enhanced to try to promote enhanced interaction with the members of your lab and also colleagues in the same or at least similar field. And I'll kind of explain how we try to do this through the format. And then develop scientific presentation skills. Okay, and we have a specific mechanism we started last year that I think really does help this. Okay, so just for those who came in, I just mentioned that we have 3 main goals of the qualifying exam. Yes, it is an evaluative exam, and at the same time, the 3 goals are really to help students develop a broad and deep understanding of their field, to enhance the interaction between the student, i.e. each of you, your lab and colleagues in similar fields, and to develop scientific presentation skills. Okay, I'm going to break it down. I'm going to talk about the written document first, then I'll talk about the oral exam. Please feel free to ask any questions whenever, large or small. So the written document itself, I'm going to focus on that now. 20 pages, double spaced. Does not include references. Kind of sort of includes figures. I mean, if it's 21 pages, we're not going to care. If it's 25 pages, we're probably going to care. Okay? Double spaced. The margins and all that, I can't remember, but we specify. Just follow. Okay, format. Abstract, comprehensive review, substantive experimental approach, which really means either one big specific aim or 2. It's kind of what people do. And a reading requirement, and I'll get into the reading requirement. Okay? So just to give you some ballpark idea of pages. So about 1 to 2 pages for the abstract, not surprisingly. Comprehensive review. I always say we want it around 75%, so 13 to 14 pages. Substantive experimental approach, about 5 pages. This is kind of what we suggest. What actually happens is this is usually about 6 to 7 pages, and this is about 12 or 13. So it's really, theoretically from my perspective, because our focus is kind of really broad, deep understanding of your field, 13, 14, 15 pages here, and 5 or so here. But in reality, I think because you really do have to develop the logic of the experimental aim, this tends to be 6 or 7, and this tends to be 12. Just telling you what happens, and that's fine. Okay, what do we want in the abstract? Start over here. Okay, clearly you need to define the field, state your problem, and then by state problem, what is not known, what the limitation is. It depends on, if you're doing it, if it's more of a technical approach, it's kind of a limitation, what's not known, something to that effect. Okay, that's one. B would then be B is then very important. Define your hypothesis or your question. Some people, some faculty like hypotheses better. I tend to prefer questions. There's not a huge difference. You know, X-rays are mutagenic, that's a hypothesis. Are X-rays mutagenic? That would be a question. Same thing, but just stated slightly differently. And then tell us why it's important. Or, you know, it doesn't have to be in this order, but it should be explicitly stated in some sense and be clear why this is an important problem to solve. Okay. Questions? Lindsay?
Do we mention methodology or anything?
Okay. So Lindsay, this is just for those who might be watching. Lindsay asked whether or not we should mention methodology. In the abstract, yeah, yes. So define your hypothesis, kind of what you will do, okay, after the hypothesis. Methodology necessarily, not a lot of detail, right, because it's short, but here's my hypothesis, do microbes have an impact on kind of uterine health or something like that, potentially for you. That would be the question. The hypothesis would be they do have an impact, and I'm going to assess this question or hypothesis by doing X, Y, Z. So yes, bring that out. The abstract is focused more on this than the comprehensive review, right? The abstract's really focused on this. Your talk will also be focused primarily on this and not the comprehensive review. The comprehensive review is really to help you get into your lab and get a broad and deep understanding. Okay? Any other questions? Okay. Comprehensive review. We want you to, give a comprehensive review. Identify we want you to identify the key outstanding questions in the field, one of which should be the question that you are going to study in your experimental aim or approach. Okay? And then, identify the key outstanding questions in the field, break the field down into different sections, give us a nice, strong, comprehensive overview. Okay? Then there's a transition. Where you focus from a broad overview into exactly what you're going to do. And that should kind of bring out the logic and rationale of why this specific question is important and what you're going to do. Okay. Then there's a substantive experimental approach, about 5 pages, which translates to 6 or 7. Okay. This can be exactly what you expect to do. I'm going to call that on topic, so it can be, and most, essentially all students write it on something they expect to do in their thesis research. Of course, what you expect to do and what you do are not always the same thing, but that's okay. And it should have the potential to shift. It should have the potential to shift or move the field forward. So not incremental, but potentially important. Okay, does that make sense? Okay. Reading requirement. Okay. At least, so equal to or greater than 50 papers, and these are the 50 most important papers in your field. We don't really know, if you have 5 people and you ask them what are the 50 most important papers in your field, you're going to get 5 different answers. But we want you to read broadly and deeply in your chosen field of thesis research so that you have a very good background in your chosen field of thesis research as you are setting foot in your lab. Okay, does that make sense? Okay, so that's important. The other thing, you can talk to and interact with anyone. There are no limits, okay? So if reading papers, and you have questions, talk to your lab mates, Okay, it's kind of the real world, and our logic is, you know, in science, the more you interact with people, usually the better it is. And if you're going to interact broadly with a lot of students, faculty, and postdocs in writing your qualifying exam, you're likely to interact broadly with a lot of people during graduate school. So it's a faithful proxy of what's going to happen throughout the rest of your career. Okay? And we actually encourage people. Some programs don't want people to interact too much. We do, and that's our logic. So it's either black or white, and I think black and white is easy to deal with, but shades of gray aren't, so we just let everybody interact with whoever they want, and we actually recommend and encourage people to interact with not only their faculty, mentor other faculty if you can, definitely postdocs, grad students, anyone in your lab. Okay. Sometimes there may be some faculty members who will sit there and say, oh, am I allowed to? Because I know some programs don't. Just tell them, yes, this program. You can show them the video too. Okay, makes sense? That's the written document. Timeline, this you should all know. Okay, timeline. July 1st, I mean, some of you I know just got into labs and we've moved it back, but that, you know, those of you who that's of interest, we've talked, your chair should know. But July 1st abstract is due. For some of you, I think it is August 1st. September 1st, draft of the entire document would be due. If it was, you know, push it back a month if this was August 1st. And then October 1st, ideally have the QE scheduled. This is admittedly a very optimistic timeline for this aspect. I don't think it's, abstracts isn't too much. The September one, I think that's doable. This is going to be pushing it. We get it. We really, really want people to get it done, definitely before kind of December, because not getting the qualifying exam done during December, then you go into January, and it's a morass. It's just a complete morass with recruiting. It's just hard to get it done. Okay, so shoot for October 1st. That would be great. July 1st, September 1st, draft due to your chair, same chair. The chair will give you one round of feedback on the abstract, written and probably verbal, and one round of feedback on the entire draft. Okay, so clearly the better abstract, and this, by draft, I really mean final polished draft. Okay, it should be good. You can get feedback from anyone, you can give it to people, grad students, people in the lab, your postdocs, your PI, you can get feedback from whomever you want. Okay, one round with the chair, just give it to the chair once because it's easier that way. The more people you give it to, which also implies the earlier you give it to them, the tougher people you give it to, the better. Okay? It's actually good to give it to people, not people who are mean, but people who are tough and harsh in terms of being very critical. Better early than later, right? Better have it be critiqued in a very tough manner by people before the exam than in a very tough manner by the 3 faculty members on your exam, right? Okay.
When do we find out the other 2 people?
Yeah, I'll get to that. That's a good question. Okay. The other thing, when you're writing this document, be thinking about your talk and how you want to set up your schematics and how your slides. Okay. So Eddie asked, when do you find out your whole committee? So we've done it a number of ways. And the way we're doing it now, which is logistically the easiest way, you will know beforehand. It's not like MCB where you walk in and it's a blank slate. You'll know. But the way we do it is you have your chair set. All of you should know your chair. And then once you get ready to schedule, we look down your list and we try to schedule people who are present around that time. Historically, what we did before is you knew maybe not right now, but pretty close to like 2 or 3 months before, you knew your committee. And then when we went to schedule that committee for when you were ready, well, this person wasn't in town for 2 weeks and it was going to be a month. So you'll know the committee probably 2 weeks before, 1 to 2 weeks before the exam, but not much before that, just because logistically it makes it easier to schedule.
So it's not too late to send you the list?
No. That's so if you have, it's too late to send me who if you know your chair is set. But other than that, it is not too late to send me the list of faculty members you want, because what will happen both for DB and genetics is, depending on what the field is. If it's a field I know really well, I'll be like, yeah, these people are good. I'll add this person too. Usually we just go down that list. So the longer that 2 vetoes, but the longer your people who I would like on, the longer that list is, makes our lives easier, frankly. Okay? So yes, please send me, if you haven't sent me that list, send it to me. Okay. We're flexible, but please get it done before the next semester. Okay, that's that. So oral. Okay, I'm going to switch to the second part, the written. I mean, they're all related, but the oral defense of the document. Your committee. Okay, talk about your committee, which we kind of just talked about. Format, stage, if you will, i.e. what happens, like what it looks like when you walk into the room, and then a real kind of a check on just being realistic. Committee, your chair, 2 others, send me those, we talked about that. Format, it's really you talk, they listen. In general, now in the new format, people just interrupt throughout the talk. I think that is better. Kind of breaks the ice in some way if they interrupt you really quickly. And somehow in some way it helps students relax a little bit more. Usually it's 1 to 1.5 hours, closer to 1.5 hours. If you get done in 1 hour, don't quote me on this, but usually that's a good sign. Doesn't mean that if you get done in 1.5, it's a bad outcome. It's just 1.5 is probably the average one. But if you get done really early, don't worry, it's usually a good thing. Usually. There are always exceptions. Okay. Stage. What do I mean by stage? It's you and it's 3 faculty members. Okay. What'll happen is could be in this room in many cases. 521, 522. You'll be all set up. They'll come in. You will get kicked out of the room. They will go over grades, other things, so forth and so on. And more or less they'll go over what'd you think about the document itself. If there are faculty members who haven't done a lot of genetics or DB qualifying exams, the chair will go over the format. They'll bring you back in. You give your talk. They interrupt your talk, and I'm going to get to this, should be about 20 to 25 minutes or as short as is humanly possible. But that's what it is. You, student, plus 3 faculty members. You will be nervous, okay? It's okay. Everyone expects you to be nervous. And you just have to accept it. Don't try to run away from your anxiety. I was a little bit like that in high school and college. Oh my God, I have to give a talk. Oh my God. And so I'm really nervous because I suffered, or still do, from stage fright in many ways. But if you try to run away from your anxiety, the anxiety is within you. So wherever you run, it kind of goes with you. So you just have to accept it. And if you accept it, it actually helps. Okay? Someone told me that once. I looked at him. It's like, really? And you're like, okay, I'm going to be nervous. And it's like, okay, it helps. Because you can use it in a positive way. Okay. So that's kind of just the big picture. now let's go into your talk. As short as is humanly possible, given that you have to tell us everything we need to know but nothing else. Okay? So you want to give us all the information we really need and nothing else. Okay? Think of horse races and the horses, they put blinders on them. What you want to do is put kind of blinders, i.e. focus your committee on the questions you want to focus on, right? And your talk is focused. It's focused on your experimental approach. Okay? The comprehensive review is really broad, deep understanding in your field, but your talk is going to focus on the experimental approach and really focus people on it. Okay? So, as short as is humanly possible, what do I mean by that? About 20 to 25 minutes. If it's a 45-minute talk, it is too long. Quan, if you know Quan, he's a second-year genetics student. I think his was about 15 minutes. Okay? That's the short, and it was good. I mean, I'll talk to you about a mechanism that we have, that I run, which is called the CMB Presentation Workshop, where we give practice talks and then they get trashed by me and others. I heard it. It was good. It was 15 minutes or so, 14 slides. 20 to 25 minutes means somewhere on the order of 15 to 25 slides. You shouldn't need more than that. And if you do, you need to whittle it down to that. Okay, 25 would be high, 15 would, I think, be about right. Okay. So break it down. So you're going to have an introduction. Okay. Focused and concise. Define the big picture, define the field briefly and why it's important to study. Define the key unanswered question or the limitation that you're going to go after, what isn't known. State your hypothesis or question. Okay. I.e., tell us all we need to know but nothing else. We really define the question early, and you can all give practice talks in this workshop. I'll talk about that a little bit more. That's a big thing for me. Okay, let me put it a different way. I'm harping on as short as is humanly possible. To put it a different way, let's say you give a really broad, comprehensive overview in this intro that goes maybe 10 or so minutes as opposed to maybe 3 or 4 or 5. But if it's 10 or 15 minutes, you talk about everything that's related in the field. Faculty members can be a little ADD. Oh, I'm interested in this, let's talk about this. Oh, I'm interested in this, let's talk about this. Oh, you brought that up, that's interesting. Okay, you now have to answer all those questions, right? Which is okay if you know them all. Okay? But if you focus it and it's really concise, you're in charge. You're taking the audience and you're saying, I'm going to talk about this. Okay? And this is why I want to talk about this. This is why it is important. This is what we don't know. And this is what I'm going to test to figure out something, to learn and understand that which we don't know. Okay. So in essence, you want to focus the questions on your experimental approach and the questions that you are asking, and you do it in the introduction. Okay, what else? Questions. Remember, it's you and 3 faculty members. You speak, we ask questions, you answer the questions. Typically, they're asked throughout the talk. I think that's better. You're in charge again. I know you don't feel like you're in charge when you're going to do it, but nonetheless you are. It is fine to sit there and say, I would appreciate if you just ask questions throughout the talk. Depending upon who your chair is, they may just say, we're going to ask questions throughout the talk. I think that is better. Okay? Sometimes, historically, this is a historical thing, historically we used to hold them to the end, which just wasn't as good, because then you'd have to go, in essence, remember that slide? Let's go back to that slide. And you go back to that slide, and then the student would have to remember what they were talking about at that slide. It's better this way. Questions? Usually throughout the talk. What type? What types of questions? Okay. Usually there are 3 types of questions. Clarification, this is usually in the introduction, knowledge-based questions and questions that focus on the experiments that you're doing. Most of it's going to be on the experiments, okay? But there'll be some knowledge-based in the introduction usually, and clarification a little bit throughout, okay? What if you know the answer? Great. What happens if you don't know the answer? Don't bluff. Someone in the room will know. If you don't know the answer, it is fine to say, I don't know the answer to that question. And so what'll happen there, often, not always, because a lot of times when we're asking questions, we kind of know the answer. So what'll happen is, well, I don't really know the answer to that. They very well may restate the question in a slightly different way and give you slightly more information and try to walk you through the logic of it. Okay? Sometimes it's an honest question, they really don't know the answer, they won't do that in that case, but there are sometimes, especially with some experimental approaches, where they'll walk you through it. Okay? So just be aware that that may happen. The other thing, if they ask a question and you don't know the answer to that question, but you know the answer, so sometimes if they're asking a question about A, and A is here, there's a field B that overlaps with A. You can say something, I don't know that much about A, but I know a fair amount about B, which is related. Would you like me to talk about that? Okay. Again, it's going to depend on the question, the person asking the question, and a lot of different things. But if that's me, I'd be like, yeah, sure, tell me what you know. We want to know what you know. We get that you're not going to know everything. We get that you're not going to know every answer to all of the questions we ask. But we want to know what you do know, and we want to know if you can think critically about experiments. Okay? What else do I want to say? Don't bluff, yeah. A good thing to do when they ask a question is to repeat the question. Okay. So they ask a question, and if you repeat it, it does 2 things. One, it makes sure that you understand the question. Sometimes faculty members ask really clear, precise questions, but not always. And it's probably 50-50. Sometimes the questions will be a little bit unclear, so you can say, so just to rephrase the question, are you asking X? And they'll be like, yes. So 1, make sure you understand the question, and 2, it buys you time. Right? As you're sitting there rephrasing the question, both consciously and subconsciously, you're thinking about that question. So you buy yourself a little bit of time. It's good, and it's actually very effective. Do not do it for the first time at the qualifying exam. When you practice, and I'll get to practicing, practice that first. Okay? If you do it now commonly, then you've already practiced. But if you don't do it commonly, and most students don't, get in the practice of doing it. Get over the, ooh, this seems a little artificial aspect of it, because that'll make you feel, that'll increase anxiety, and you don't want to do that. With experiments, they may ask, so you do step X, Y, Z, and you expect to get, this result. What else do you expect to get? They'll probably flesh it out. And if it's hard sometimes if you actually haven't done that experimental approach to know exactly what else you might get. When you do, let's say you're going to do an IP pull down. Okay, you're going to assess whether or not you pull down a set of proteins. Well, IP pull downs can be really kind of dirty. And so what else might you pull down? Do you really think you're only going to pull that down? And how are you going to confirm it? They'll just talk about logic and stuff. Mostly it's going to be logic driven. Most of the time, listen, there are exceptions to everything I'm probably going to say today. Most of the time, we're looking for your ability to think in big picture. Most faculty do not get into the minutiae and the real minutiae of the experimental details. There are exceptions to that. Okay, but most do not. We want you, can you think logically? You know, you'll figure out how to do the experiment. I don't care about molarity. I don't care about concentrations. Big picture, can you think? If you see a logic in your approach while you're up there, admit it. Okay, oh, maybe I should do it a different way. That's hard to do, admittedly, if you're on your feet. Oh, maybe there's a problem. It's fine. It's easy to sit there and say, maybe there's a problem. I see the point. Oh, but what's then really difficult is for you to sit there and figure out how to solve it. Okay, and if you sit there and say, okay, I see there's maybe a problem with this approach. I can't really, I see your point, and yeah, there's a problem here. I can't think off the top of my head how to fix it. I'd have to take some time to do that, but that's a problem. That's fine, okay? It's honest, and we get it that you're up there and you're nervous, and the longer the exam goes, the less ability you have to think. After an hour and a half of teaching, I'm not very smart. I'm much smarter at the beginning of your class than at the end. We get it after an hour and a half. And let's face it, an exam where it's you and 3 faculty members is more stressful than me getting up and teaching. Okay, no one's trying to fail you, they're trying to get you through. Don't worry about that. Okay. Yeah, introduction, focus, concise. Then I didn't really get into, I just said questions. But then get into the experiments. I'm not going into that into great detail. But what you want to do is define your question. Here's the question, here's the approach I'm going to take. In general, I think it's very helpful to have kind of schematic, a simple schematic flow chart that kind of gives the big picture logic of, in one simple slide, what you're doing and how you're going to do it. And then you kind of go in another slide or a few slides to exactly what you're doing in more detail. That's helpful. Okay. How to prep. Okay, how to prep for the talk. When you are writing, think about it. Think about the slides. The most important one, I think, which I just said, is a schematic that really outlines your approach simply. And again, this I'll talk about at the CMB presentation workshop. We go over that. And I'll go over the details of what we do in that in a minute. I think I have it down. Yeah, that is. Okay. So while you're writing, think about the schematics. While you're writing, if you can, have a schematic for your document that is very simple, and you can, of course, reuse that for the talk, that's fine. But think about it so that during that 2-week period when you give it to the full draft to your chair, okay, start working on your talk. Okay, so think about it so that don't have it so disconnected that, okay, I'm going to do the writing and then I'm going to do the talk. You're kind of, when you're doing the writing, you're thinking about, they're essentially the same thing in some manner, different forms of presentation, but be working on it the same way. It makes your life easier. Number of slides, I already went over that. I'd say 15 to 25, closer to 15. Okay. Construct your talk, hourglass. Start big, get to the details, end big. Okay. Just a simple way to think about it. In general, you just have to, it's mostly you, PowerPoint, figuring it out, but construct your talk, get the talk together. In general, bullet points are not very helpful. Schematics are helpful. Things that connect are helpful. Bullet points do not connect. They're not helpful. Not everyone agrees with that, but most people do, and there are actually studies show that people don't remember bullet points. Okay, but you're going to have to sit down and construct your talk. Once you get it, practice a few times with yourself, but then the most important thing Practice, practice, practice in front of people. Okay, and get their feedback. And initially I would say, listen, let's practice, and I want your feedback on how I can make this talk a better talk. Sometimes I think students start, oh, what about this science question? What about that science question? Yeah, that's great. The purpose of this initially is to get a good talk. Okay? So practice, 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 and then edit, edit, edit. You know, go back, change it, make it better, make it smooth. Okay? In general, as a rule of thumb, the more senior the person, the better, more critical feedback you're going to get. Senior grad students in general are better than junior grad students. There are exceptions to this, but that's in general true. Postdocs are in general better than senior grad students. Faculty members are better than postdocs and all the others. Just because we've been through it more, we know what we want, and that's what it is, okay? So practice, 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 I'd say 3 to 5 times, get a lot of different feedback on it, and have it be a clear talk, okay? So the CMB Presentation Club workshop, I don't know what I call it, CMB presentation, and then I call it something else. What do we do? It's similar but much more involved than the rotation talks that many of you did. You get up, you give a practice talk of your qualifying exam. I videotape it if you want. You don't have to, but most of them get it videotaped. And then we sit around and talk about, usually there's a number of people there and they'll give their comments, and then I go through slide by slide with it and say, do this, do that, do this, this is good, you know, change this, bring this out more. When did you ask your question? On this slide. What slide is it? Well, it's slide 12. How many slides do you have? 16. Well, do you think maybe it should be earlier? Yes. Those type of things. But students have found it very helpful, and it's, you know, it's tough in the sense that I'm very critical. I'm not mean, but it's critical, and it makes the talk better, okay? And then you can go back and either take notes, or you can just, I videotape the whole thing so you can go back and listen to what we say. I'll have a sign up for that later. Okay, but if you practice and practice and practice, at some point you're going to be like, okay, I feel comfortable. I feel comfortable enough giving this talk. I remember when I was a grad student, I practiced it. Like I said, I had stage fright, but I practiced it with Grace, who's now a faculty member. She was a postdoc in the lab. She's a faculty member at Wisconsin. We practiced it a few times, and I remember finishing kind of at the end of once, and I was just like, okay, I'm good. Right? That wasn't the first practice talk. That was probably the 3rd, 4th, or 5th practice talk. But at some point, I'm like, okay, I'm good. And if I can feel that, trust me, all of you can feel that, because I do struggle probably more than most people, or I did struggle more than most people with kind of stage fright. Okay, so once you get the talk ready, I kind of think of these as slightly different things. Once you get the talk ready, okay, then give the talk and give it to, again, junior grad students, senior grad students. The SRS series are good for this. Get grilled. The focus now, the talk I'm pretty happy with. You know, if you have little points about it, fine, I can change it. But the focus now is to get grilled. Ask me questions about anything and everything with respect to what I'm presenting, the experimental approach. Okay? You, ideally, this is almost impossible, but ideally, the practice session should be harder than the qualifying exams, and you should get all the questions. The harder that can happen, but it's unlikely you're going to get all the questions asked in the SRSs that you will in the qualifying exam. Nonetheless, that's the goal, right? If you can get grilled and you can get used to handling questions, okay? Repeat the question, go to the board, okay? There's a big difference between sitting down and writing and coming up here and explaining something on the board, so practice doing it in these practice sessions. Okay. Goals of the qualifying exam. Broad, deep understanding of field. Okay. How do we do that? Well, comprehensive review, you know, read broadly and deeply in the field. Enhance interaction with lab and colleagues. Well, we want you to interact. We actively want you to interact with the members of your lab, the members of other adjacent labs, the member of labs that may not be adjacent but work on similar things. We want you to do that. Develop scientific presentation skills. Well, you have to give a talk. And we have a mechanism that I think is pretty effective at providing critical and feedback on your presentation and presentation skills. The way to get better at presentation skills is to practice and to give more talks. Questions? That's my spiel. I have some other big picture points in terms of what you need to do now that you're done essentially classwork in most cases. No questions?
When did the CMB presentation start?
September. You'll get an email. I'm doing, right now we're going through, so it's generally for second and third year students, and it's for qualifying exams and thesis proposals in general. And what's been interesting, this I did not expect, so I videotaped them, as I told you. And we just started a year ago, and we just started to have some students who had done their qualifying exam, and now they're doing their thesis proposal. And the difference between the quality of the presentation for the qualifying exam and the thesis proposal, not just the presentation, but also their comfort and confidence in speaking, it was, I mean, the difference was stark. And in one case, I didn't videotape because it was in essence an SRS, and I got there late and whatever. But the other one I did videotape, and I was talking to her, I was like, do you still have your video from the qualifying exam practice? She's like, yeah. I said, just watch 6-7 minutes of that, and then watch this one. It was just stark. And I chatted with her afterwards. She's like, yeah, I felt much better. So it was good. That was nice to see, right? Okay. Any other?
I have a question. How much work should we propose? I know you said like 1 or 2 specific aims.
Yeah. It's a substantive experimental approach that should be able to, you know, make headway into an important problem.
Okay.
It's a little, it shouldn't be simply incremental, and right, it should be meaty.
Okay.
It's not, I mean, the other thing to do is look at other people's.
Okay.
We should have, but we don't. We don't have like a library of them. But nonetheless, you all know senior students. Lucy?
What kind of faculty are going to be on the committee? Is it only like genetics department faculty, or is it going to be?
It's largely up to you, right? Because that list, I mean, I'm being completely serious when I say the list we get from you, that list we will use. Now, it could be that everyone on that list can't make it at that time and we have to go deeper, but nonetheless, we will go through that. And in general, we try to have someone as chair be either a present or past steering committee member of the relevant program, okay? Because we want to try to have some level of standardization of an exam format that cannot be perfectly standardized, right? So we do try to have people who, at least one member, either sitting or past sitting member of the steering committee, who's had a lot of experience on kind of doing these exams. In general, that's what we try. Might be a little trickier this year with genetics because there are 18 or so of you, and harder with 18 because it's more. But that's what we try to do. So yes, I mean, if you want, so you're working kind of in microbiology, yeah, I mean, definitely if you think, if you and David like, oh, this person or this person would be good, recommend it. You know, they may say, no, I don't have any genetic students, I'm not going to do it, but we can ask. Other questions? Okay, just some big picture points. So now pretty much, could have done this at the beginning, but I didn't. So, you know, you're done with respect, largely with respect to the classwork and the general knowledge exam. So really what stands between you and a PhD is pretty much you, your lab, your bench, and a lot of hard work, okay? And I've said this before, I say it at orientation. I think with orientation, you're just starting grad school, so a lot of people forget. To succeed, you really need to do a number of things. I'm going to say the same thing in a few different ways. You need to work hard, you need to believe, and you need to be happy. Okay? What do I mean by work hard? Work hard, think hard, do experiments. Work hard. You have to physically work hard. You have to do experiments. You have to go to the lab, be there a lot. You know, some of you are more computational, some of you are more wet bench, but whatever. You do experiments in either way, or you do analysis in either way. You have to put in the time. when you're putting in the time, you have to think. You can't just do, you have to think critically about what you're doing and why. And it's hard because, you know, when you're in the lab, the analogy is the forest and the trees. When you're in the lab at the bench doing the experiments or at the computer doing the analysis, you're sometimes out on, there's an individual tree, you're out on a branch, you're out on a small branch, you're looking at the twigs and the leaves. That's important. At the same time, when you're doing that, you need to step back and think about the big picture and continually do that. Because, you know, thinking about the twigs, the little things, and taking care of the little things is critically important. And at the same time, you know, PhD is really a professional problem solver. You want to think about the big picture as well. Believe, yeah, experiments don't always work. Science will throw you curveballs. Science will knock you down at some point. All of us have been knocked down many times by science. It's not particularly pleasant. Get up, move forward. Be happy. If you like the lab, you like the people, you like the question, you know, damn, it's much easier to work hard and be happy and believe in yourself. It just is. So if you're not happy and things aren't going well, come talk to me. You know, I don't mean a day, you get up, shit.